Hi, I'm Jonathan Oxer, and this is SuperHouse. Now, I have a bunch of these IP cameras scattered around the house. I'm going to show you today how to get power to them. A lot of them are in very inaccessible locations like this, mounted up under the eaves of the garage, and getting power to it is not always easy. So let's check out the options. Now there are four fairly obvious ways I can think of to get power out to a remote camera. Now the first and most obvious is do exactly what the manufacturer intended. Now your camera might be mounted somewhere out like under the eaves as I showed you, and the particular cameras that I use most commonly are these Foscam cameras, and they have connections on the back for 5 volts at 2 amps, Ethernet and Wi-Fi, and also audio in and out, so you can do audio monitoring. So what you need to do is use the supplied power supply, which is a 5 volt 2 amp power supply. But that means you've got to get mains power out to it somehow. So you need 230 volts, 240 volts, whatever your local power supply is, out in the region of the camera. Now you may think that the obvious solution is to mount the power supply somewhere remote, run long wires to it, and use that to splice in. The thing is that at 5 volts at up to a couple of amps, you're going to get pretty big voltage drop across that. So you really need to get the power supply close. You need the 5 volt voltage regulator to be fairly close to the camera. And that can be a bit of a pain. I've got a couple of cameras that are mounted like this, but getting the mains out to them is difficult. So another technique is to use commercial power over Ethernet, and you use some power sourcing equipment, something like an Ethernet switch which has built-in PoE support. And then out near your camera, what you need is a PoE splitter. And what the PoE splitter does is take the connection from the Ethernet switch. So this is just Cat5 cable that goes out to the region of your camera, and it provides a Cat5 output, which provides the data connection to your camera. And in all of these cases, you can also choose to use Wi-Fi if you prefer. But it gives you Ethernet all the way to your camera. But what it also does is have a built-in voltage regulator and provide a power output that you can then supply straight to your camera. And I've got an example of one of those devices. This is a TP-Link PoE splitter, and I'll show you some more details of this in just a moment. But by mounting this near your camera and then running Ethernet out to it, you can tap out of this both power and Ethernet for the camera. So this particular device is a PoE splitter. That is okay if you've got a commercial PoE switch. You can also do something very similar using a regular switch and really cheapy do-it-yourself Ethernet or power over Ethernet. So in that case, what you do is you have a device like a power over Ethernet injector, and that takes local power and it uses spare pairs on the Ethernet cable to make that available to devices at the other end. So what you need in that case is something very similar. You need a splitter, but instead of working with the commercial 48 volt power over Ethernet, it just works with whatever you use. And in fact, it can be as simple as a basic voltage regulator. So this is a really handy technique, and I'm going to show you specifically how to do this one as well. So what happens is that your Ethernet goes through to the camera, and you connect to the spare pairs on the Ethernet cable with this little voltage regulator. So what we have here is a 5 volt voltage regulator, and the output of that goes to your camera. Now I'm going to show you how to do that using a tiny device called a Freetronics PR28V, which is a little switch mode power supply. Basically it's a wide input voltage range, and it just gives you a regulated 5 volts or 7.5 volts output. I'm going to switch it to 5 volts output, mount this probably actually inside the camera so that it's a really neat system, and show you how that works. Now there is another method, and this is something that a lot of people think sounds really tempting at first, but then it turns out not to work out as well as you would think. And that is, if you have lots of trouble getting power to your camera, these cameras support Wi-Fi, and so the obvious solution is, why not just provide local power? Don't run any cable to it at all. Instead use some solar cells. So you end up with the solar cells. Then, because you want the camera to run at night, you'll need a battery, and you'll need a charger for the battery that takes the power from the solar cells and manages the battery charging. Then you need a voltage regulator, and that sends the power to the camera. Okay, so in theory this will all work fine, and you'll have a nice little self-contained system that you can deploy at the end of your driveway or somewhere that's difficult to get cable to. However, there are some traps with this. These cameras take more power than you would expect, particularly when they fire up at night, because they have infrared illuminators built in, and they can draw a fair bit of power. They've got servo motors for pan tilt function, and when you start adding up doing the numbers, you actually need an awful lot of power because you need to charge the battery during the day, and it needs to run entirely off the battery during the night when the IR illuminator is running. You actually need a lot of solar cells, and you need a big battery capacity just to run a little camera like this. So we'll measure the current in a moment, and I'll show you how it all works out, and we'll do the numbers. So let's look at how to actually do this. Of course, the only way to know for sure how much power one of these things is using is to measure it. So here I have the Foscam, and I have it plugged into a little lead which goes to my bench power supply. I've got 5 volts running into the camera, and you can see that just sitting here doing nothing, it's pulling 420 odd milliamps, which is quite a lot actually. That's more than I expected. So let's try a couple of things and see how it affects it. On the front of the camera, it has a little light sensor, and it uses that to turn the infrared illuminator on or off, and it overrides. So if there is really good illumination, even if you turn the illuminator on, it keeps the LEDs off. So I'm going to block that up totally, so the camera is just seeing nothing but black, and the IR illuminator is now off. So it's now pulling, it's jumping around between 410 and 420 milliamps. I'll turn the illuminator on, and it's made bugger all difference. 430. It's actually pulling very, very little. I'm surprised by how little difference it makes when the illuminator is on. Now, one other thing that's interesting, you can see at the moment it's pulling around 420. I'll get back to that in a second. First, let's have a look at what happens with the pan tilt mount. So I've just put it into vertical patrol mode, and you can see it's added about 270 milliamps of current draw just by turning on one of the servos. So I'll turn on the horizontal patrol servo as well. So this is the pan servo, and it's now pulling just under an amp of current at 5 volts, just running the pan tilt servo, so about 420 milliamps or so for the camera, and the rest of that, so over half an amp, just on running those little servo motors. That is surprising. I actually thought that a lot more of this would go into the illuminator and a lot less into those servos. But there's something else that's interesting too, just something that's worth observing. I've just turned off the servos, so it's sitting there running at about 420 milliamps, which is what we saw before. I'll unplug the Ethernet cable, and you can see that the current draw has dropped. It's down to around 320, give or take, milliamps. It's jumping around a little bit. And then I'll plug the Ethernet cable back in, and you'll see that current consumption will go back up in a moment once it detects the network. There it goes. So up to about 420 odd milliamps. So it's spending about 100 milliamps continuously just maintaining the Ethernet connection. So yeah, power gets used in unusual places. Anyway, I'm now going to pull one of these apart. Well, actually, before we do that, I'll show you how to power these using a PoE splitter. Right now I have the other end of this Ethernet cable plugged into a commercial switch with power over Ethernet support built in. And there's a really handy little trick you can use to get power off the cable. So right now there is 48 volts available on this cable in addition to the data connection. That is to use one of these PoE splitters. What you do is connect to the powered Ethernet segment on one side. There's a little selector on the side so you can specify what output voltage you want. And on the other end you have data out and power. So what I'm going to do is disconnect the Ethernet cable from the camera, plug it into the input of the splitter, and you can see here the splitter is powered up already. It's getting power off the cable. Then I'll take this extra short Ethernet cable, plug it into the switch, plug it into the data connection on the splitter. So we now have a data connection from the network all the way through to the camera, but it's still not powered. So the next step is to use one of these little jumper cables. And I had to make this one up because I didn't have a cable that was 2.1 millimeter from here to 1.6 millimeter or whatever it is on the back of the camera. I'll plug that into the power connection, and you can see the camera is now powered up and it's now got a data connection. So this camera is now powered entirely via the network cable. That's really handy if you have an Ethernet switch with PoE support, but it can be kind of expensive. PoE switches are expensive. These little splitters, I can't remember how much it is, it's a while since I bought one, but I think they're around $30 to $40. But it is a very handy way to do it. What I'm going to show you next is how to do this the cheapy DIY way, and we'll modify a camera and set it up to mount at the front door of my house, because that's where I need to put the next camera. I'm not going to use this black camera though, because everything's painted white out there. I'm going to use this white camera. We'll pull it apart and I'll show you how to modify it. So for this particular method, we're going to need a couple of things. To replace the PoE splitter, we're going to instead use a little device called a PR28V, which is a power regulator. It's a switch mode power supply basically. It takes up to 28 volts input and gives you either 7.5 or 5 volts output. And because it's switch mode, it's very efficient, doesn't run hot. So we can feed it 18, 20, 24 volts without any problem, and it won't overheat inside the camera. So we also need a PoE injector, and you can just cut the cable. I've shown how to do that before. This is an injector that you plug in series with the cable and apply power, and it just uses the spare pairs on the cable and supplies it down the wire. So we'll use that in a little bit. What I've got here is a PR28V with a couple of cables already attached to it. So I'll see if we can get in close to the camera. It may not be able to focus. Okay, so that's the voltage regulator with the cables, and basically there is a pair of wires for the input, pair of wires for output, and there's a little solder jumper on the back, so I've put solder across that, and that sets it into 5 volt output mode. And the black and red are the 5 volts output, blue and white are the input. So now we need to pull this camera apart and connect into the back of this Ethernet jack. Now these particular cameras have screws hidden under these quality control stickers and also under these little rubber feet at the back. So I'll pop those feet off, get them out of the way. They can be quite aggressively stuck on. Yay, finally got it out. So I'll take off those two screws, and then if you don't know that they are there, the next two screws can fool you. Handy magnetic screwdriver to get those out. The easiest thing to do is just punch right on through the quality control sticker and connect to the screw. So that one, and punch a hole in that sticker, undo this screw, and there is nothing, I know from experience because I've modded these cameras before, there is nothing under that particular foot. So then we should be able to peel the bottom off this camera. There we go, get that out of the way. And this is the controller in the camera. So there are a couple of big chips there. There's a WinBond chip, I'm not even sure what that is, I haven't looked at the details of what these are, but presumably one of those would be an Ethernet driver chip. And obviously there's some video processing and a microcontroller of some kind going on in there, because it needs to serve up the web page. Now, just out of interest, you don't actually need to do this to mod the camera. I'm going to lift this PCB out of the way so we can see what's inside. Ah, look, now you can see that there is a daughter board in there. I'll see if I can get a good angle on the camera and get some light. This daughter board is the Wi-Fi daughter board. It's got a little connector here for the antenna, comes through to this antenna socket. So you could probably remove that if you were being really paranoid and didn't want your camera to be on Wi-Fi. And then you can see the sockets across the back for the network connection and power indicator. There's the DC input jack, which is going to be very important. We'll use that in just a moment. And the audio connections. You can also see connections through to the inside of the camera. Now there is an LED over here Is it an LED? No, that's the speaker. That's the microphone. Sorry. So microphone pickup and speaker as well. So you can see the back here of a servo motor, and this is what's surprisingly pulling that 270 milliamps or so to turn this light little camera around. So that is really quite surprising. But the important thing now is I need to make some connections back here in 4 places, 2 locations. One is the back of the RJ45 socket. Now if I look on the handy sticker on the top of this PoE injector, it shows me that what it does is provide whatever power is connected through here. Positive comes through on pins 4 and 5 on the Ethernet, and negative is on 7 and 8. So because this socket is upside down the way we're looking at it, it's actually across from the left here. So pin 8 is the one across the extreme left, and pin 1 is on the extreme right. So what's going to happen is that when power is supplied down the Ethernet cable by this injector, we're going to have the negative available on these 2 pins and the positive on these 2 pins. And what we need to do with that is send that through the voltage regulator. So what we'll do is connect from those 2 pins onto the input of the voltage regulator, and then the voltage regulator will convert whatever is sent down the wire, give us 5 volts output. Then what we do is connect onto the back of the DC jack. So this is where you would normally plug in the 5 volt 2 amp external power supply, and you also plug in the commercial PoE splitter as we saw a moment ago. What I'm going to do is wire the output of the voltage regulator onto the back of that DC jack. And that way what we can do is put the cover back on. This can all be nicely sealed up inside, and nobody will know the difference. From the outside the camera will look totally unmodified, but if we plug in an Ethernet cable and supply power down the cable in addition to data, the camera will power up. So, time to give that a go. And there we go. We've got the power from the Ethernet connection coming through here to the input to the voltage regulator, and the output of the voltage regulator going to the pins on the back of the DC jack. So the DC jack center pin here is positive, and both of the side pins are ground or negative. So it doesn't matter which side you put negative on. I just put it on the left because it was easier to get to. Positive in the middle. Over here I have just connected to pin 8 for negative, and then it goes 7, 6, 5 and 4, so 4 for positive, and that should be fine for the power being injected. So what I'll do now before I seal it up is give this a little test. Hopefully I won't let any of the magic smoke out. So I've got the voltage regulator just sitting off on the side there. I have my injector here, and I will connect up the switch side connection, and then I also need that little Ethernet cable that I used before. I'll plug that in there and into the device side of the injector. So what you need to imagine is that this cable is actually really long. This would be located back near the Ethernet switch. I just happen to have it at the end of the cable on my bench. And then this cable goes all the way through your building, wherever it is, to where your camera is mounted, and it supplies power and data to the camera. So now I just need to organize power on this. So just give me a second and I'll be right back. Okay, here we go. I've got the lab power supply fired up. I'll just get this connector out of here, and what do I need? I need this connector right here. What this should give me is a 2.1mm DC jack with this power on it. Now remember that the actual camera runs on 5 volts, but we've got this regulator on board now, so what I'll do is I'll twiddle up the input voltage a bit, take it up to something that you know the camera wouldn't be happy with normally, so it's just under 15 volts. and we'll plug it into the injector, turn on the output, and what you can see is that we now have power on the injector. It's going down the cable, and you can see that the camera is fired up. You can also see that there is power on the little PR28V here, so it's indicating that its voltage regulator is working properly, and the camera is now powered up and it's showing a network connection. So we now have a camera that's alive, and in fact it's now spinning its servo motors, so it's running through its little zeroing routine and setting itself to the center by discovering wherever the extremities are. So we're now powering this camera totally by the data cable, and all I've got to do now is cover up this voltage regulator so it doesn't shorten anything. I might just put some tape around it, maybe some heat shrink. I'll put it back inside the case. There's plenty of room in there. You can see that there's space down in here, just down near where the microphone goes. Lots of room in there. And then we can put the cover on, and as far as anybody is concerned, it's a perfectly normal unmodified camera. But now it will run totally from the network connection. So now I've got myself a chunk of heat shrink tubing. I just cut off what looks like a likely length, and we'll stick this little module down inside it. Now I've also got the trusty hot air rework station fired up over here. Now I'll stuff it inside. Yep, plenty of room. I'll just sit there right on top of the microphone. These wires shouldn't get in the way. I just need to make sure that they are clear of the mount points where the little stakes will go through for the bottom panel. You can see that this has stakes on it here, and they push down against the PCB. That's what holds it firmly in place. But as long as that all sits down flush, it's all good. So now I'll screw it back in. I'll stick the little feet back on, cover up the screw holes. Where'd the other one go? Lost it. Stuck to something. Oh well, oh there it is. It's attached to the wire. And there we have it. From the outside, apart from the fact that I've punctured the QC stickers, looks like a totally unmodified device. But I can plug it in, apply power, and we now have ourselves a functional webcam on the end of a network connection. So tomorrow, when it's daylight, I'm going to take this out the front and set it up. Has the regulator set up inside it. We have the mount screwed in place and an Ethernet cable which is going to a PoE injector at the far end. All I've got to do now is plug it in and it'll power up. There it goes, it's powering up. Now I'll screw it into place on the mounting bracket and we're done. The camera is now powered on the network, ready to go. Thanks for watching, see you next time.